Hello everyone, my name is Mr. Flamingo. In this lesson, and it's my honor and privilege to teach you today, is a review on trigonometric fundamental identities. So I know that during the week you've learned this topic already, and this is, I guess, the basis of what you're learning so that you're prepared for your quiz on Monday. So I want to go over a few examples with you all today. Do this over video. It might be a little bit different for some of you. But by doing this, perhaps if we're going too fast or going too slow, or even after over the weekend you want to review this, you can always rewatch this video and see what you don't understand and learn again that way. This particular objective, we're going to learn two things. One, to simplify certain functions so that it's reduced to its most simplest form, and also to prove certain identities to be true. Cool thing about this is that this is a topic that you'll see for the rest of your lives in high school math. This is not something that you'll see only in this class, but I teach AP Calculus and you'll see this all the time, many times. So if you get a strong fundamental basis in this, then you'll feel more confident as you go into your future math classes. So again, you've learned some of these already, so I'm going to go relatively quickly, and again, if you are if I'm going too fast, you can always rewind. Use this as a DVR to rewind and play and pause to understand. So these first set of questions, they ask us to simplify these problems. When you are simplifying trigonometric, these trigonometric functions, what I like to do is convert everything into sines and cosines. So you see here it says secant of theta and cotangent of theta, and I'm multiplying them. What I like to do is convert everything into sine and cosine. So you should know that secant is the same thing as 1 over cosine. And for simplicity's sake, I'm going to just not put the theta, and I'll just put it in the final answer. And then cotangent, if you remember using my trig identities, is the same thing as cosine over sine. So now in step one, I've converted everything into cosines and sines. In the basics of math, you notice that the cosine in the numerator cancels with the 1 in the denominator. So your answer is 1 over sine, or you could also just simplify that into cosecant theta. So that is how you simplify. Again, cosines and sines are your friends. In the second problem, I see the same thing. I have a secant and a tangent. I don't like to work with those because they're a little confusing. I don't know what cancels with what. So I'm going to convert these in just to sines and cosines. I'm going to leave the 1 as a 1. Secant squared, because it has a square, and then it says x. I'm going to leave the x out. I'm going to call this 1 over cosine squared. And then I have a minus tangent. This is a new one. Tangent is the same thing as sine squared over cosine squared. So now in my first step, as I told you, I have simplified everything and converted everything into sines and cosines. You may, there should be a squared here. You may notice that nothing cancels like the first problem. You may notice also that I can't really combine anything because I don't have a common denominator. So instead of this 1 here on the left, what I'm going to do is so this 1 right here, what I'm going to do is I'm going to erase it, and I'll say, for the sake of getting a common denominator, I'm going to call this cosine squared over cosine squared. So since it's the same thing divided by the same thing, I could just call 1 cosine squared over cosine squared to have a common denominator. So now that I have this, I could rewrite this as cosine squared plus 1 minus sine squared over cosine squared. So now I've combined everything into just one fraction, and it's a lot easier for me to manipulate this and make this simpler and easier for me to solve. So you notice here at the top, I have a cosine squared plus a 1 minus a sine squared. You should know that I have basically 3 terms on top and I have 1 term on the bottom. So what I could do is I could separate these into 2 functions or 2 fractions. And for me, since I've done this before, I noticed this. But I also noticed there's a couple of things at play here that will help me simplify this. First thing I could do is I could split this into 2 fractions that look like this. Cosine squared over cosine squared plus 1 minus sine squared over cosine squared. So for me, what I notice here is that a cosine squared over cosine squared, that's just 1. And I notice again, if I see a 1 minus sine squared or a 1 minus cosine squared, I know that's going to simplify into the other function. So that's why I knew to separate this, because I could recognize what this is going to be. So here, up here, I have cosine squared over cosine squared, so this is just going to equal 1. As I had mentioned earlier, this 1 minus sine squared means the same thing as cosine squared. And again, cosine squared over cosine squared is 1, which means I have 1 plus 1, which is also equal to 2. You should also know, I know it's something that people get nervous about, they're scared of making the wrong step or the wrong move or getting things wrong. For a lot of these problems, there's multiple ways to solve it. So this is just my way. If you happen to find and get the same answer using a different way, that's also correct. Here in number 3, I first have a cosine on the outside of a parentheses. So the very first thing I need to do is use the distributive property and apply that cosine to both terms on the inside. So on the outside I have a cosine, and again for simplicity's sake I'm going to remove the x, cosine secant, minus cosine squared. Again, I want to convert everything into sines and cosines, so I notice a secant. So I'm going to convert the secant into 1 over cosine. And right away you should notice that I have a cosine multiplied by a 1 over cosine. These will cancel, and this will leave me with a 1. So this whole thing simplifies into just 1 minus cosine squared. And again, if you notice a 1 minus cosine squared, if you notice a 1 minus sine squared, that is basically, and again, if you forgot where I got this from, if I put this in the little cloud here, you should always know the most fundamental identity, like if you forget every identity in the world and you can only memorize one trig identity, sine squared plus cosine squared equals 1 is the main one. And every time I subtract cosine squared, I get or I subtract sine squared, I can get the other function. So in this particular case, since I have 1 minus cosine squared, that means the exact same thing as sine squared. And again, I'll put the x back that I removed earlier. In number 4, I don't have a multiplication, but I do have almost everything in sines and cosines, but I have a tangent. So before I start, I'll make this sine times, and again, I'm going to remove the thetas. Sine times sine over cosine plus cosine. Here I'm going to multiply out the left term. Here I have 2 sines, so this is going to be called sine squared over cosine plus cosine. So in the previous problem, what happened was I wanted to simplify or combine and make this one term, but the problem is that I don't have a common denominator. So what I'm going to do is I'm going to multiply this piece over here times cosine over cosine, and by doing so I can get a common denominator. So if you follow me, I'm going to multiply this by cosine over cosine, and I'm allowed to because it's like multiplying by 1. And if I multiply by cosine over cosine, let me erase this, I'm going to get cosine squared over cosine. And you're probably like, okay, that makes sense because this cosine squared over cosine means the exact same thing as just regular cosine. I just do it like this so I get a common denominator. Since I have a common denominator, I could just add across the numerator, so I get sine squared plus cosine squared equals cosine. And just like, as I just told you in the last problem, sine squared plus cosine squared is the most important identity. That is just equal to 1. So I get 1 over cosine. And 1 over cosine, you can leave it like that, or the correct function is secant. And in this particular problem, it was out of theta, so I'm going to make sure I add my theta back in the problem. Okay, getting a little bit harder. This particular problem, I see some squares here, and I see not only things squared, but a whole parentheses of terms that are squared. So the very first thing I'm going to have to do is the FOIL method, first, outside, inside, last. And just to give you a frame of reference what I'm doing, I'm splitting up this problem. I'll just call this S and C, and instead of saying it's squared, I'm going to multiply sine plus cosine times sine plus cosine, or sine minus cosine times sine minus cosine. So that's what I'm doing. I just put S's and C's so you know what I'm doing and where I'm getting my problem. So this part I'm going to go relatively quickly. If I do this, I'm going to get sine squared. I'm going to get 2 sine cosine when I multiply and add the two inside terms plus cosine squared. So that's the first term. On the right term, this side right over here, I'm going to get almost the same thing. I'm going to get plus sine squared minus 2 sine cosine. And let me zoom out. And I get a minus cosine squared. Oh, sorry, plus cosine squared on the outside. So here I've just done the FOIL, I've just done the distributive property, and I've multiplied everything out. Okay. Usually when you do stuff like this, you'll notice that things should cancel or combine. In this particular case, I notice that I have a 2 sine cosine and I have a minus 2 sine cosine, and those cancel. And then what I'm left with, you may notice I have a sine squared plus a cosine squared, which you know is 1, and I have another sine squared and another plus cosine squared. So essentially I have a 1 and a plus a 1, so your answer, when simplified, that ugly mess that we had at the beginning of number 5 is actually just a fancy way of saying the number 2. Okay. If you want to move on to the next page, let's go a little bit higher in difficulty in number 6 and number 7. In number 6, they look like multiplication signs, but since they're following trig functions, these are x's. Very first thing I'm going to do, what I like to do, as I've told you, is convert everything into sines and cosines. So I have a sine here, I have a 1 over cosine here, and I have a sine over cosine here. So very first step, combine them all. Now I'm going to multiply them across. This is multiplication. I don't have to get a common denominator. So what I get is sine squared over cosine squared. So I just multiply over the top, multiply the bottom. Again, it's simplified already. This is as simplified as you get. It's sine squared over cosine squared. But if you want to get it reduced into just one term, this means the exact same thing as tangent squared. And again, I'll put the x back. So convert everything into sines and cosines, and then in this particular case, I move back to tangent, so I can just make it just one nice clean function. And the last one in the particular series of simplifying, I just have tangent theta times the cosine theta, which in this particular case, again, I just have sine over cosine to convert, which is multiplied by cosine. By the rule of fractions, I have a cosine in the numerator and cosine denominator that cancel. So this particular problem, I guess the easier ones out of all of them, is sine theta when simplified. So one of the things you're expected to do or understand is when given a term, and again you'll see this all the time in pre-cal and calculus, is simplify these functions into just nice clean singular units or numbers if possible. But the second part of this you should be able to know is do basically proofs, like make sure that both sides are equal. This particular case, I'm going to solve 2 of them for you today, and when I see you in class, I'll solve the 3 for you in person. So I would like to do, or what I like to do, is the same thing. The very first thing I'm going to do is combine sines and cosines. And then whichever one is the most complicated, most complex, that's the one I'm going to try to simplify, and I use the other side. I'm going to leave it alone and not mess with it until the other complex side is fixed. So on this one, same thing. I have a secant, so I'll call that 1 over cosine. And this one I have sine. And then I have on the left side, or on the right side, I have tangent, so I'll call that sine over cosine. So again, first thing I do is combine everything into sines and cosines. You notice this one, all I have to do is multiply, and I get sine over cosine. And on the right side, I already have sine over cosine. So I know that from proofs, or for some of you in your classes, all you have to do is a little check mark to prove that they are indeed equal. For number 2, it's not as easy as number 1, but again, I will do the exact same processes like I've done. Convert everything to sines and cosines, in this case, and match the 2 sides. Here on the left, I have secant squared, so again, I can convert that to 1 over cosine squared. And again, I'm going to just remove the x's and put it back at the end of the problem. Cotangent, if you remember, is cosine squared over sine squared. And I have a pesky little 1 that I can't do anything yet, and I'll figure it out later. And again, on your right side, I have cosine squared over sine squared, the definition of cotangent. Remember that for this particular problem, when I'm proving stuff, you may notice that this right side is so much easier and simpler than on the left side. So these problems, all I'm going to do is focus all my attention on the left side. On the left side, you notice that I have a cosine squared and a cosine squared in the numerator and denominator that cancel. So when I multiply these, I'm just going to get 1 over sine squared minus 1. And again, I'm not even going to deal with the right side because that's what I want. I want my problem to look like on the left side. This almost looks like this, not quite. So I have to do something with this even further. I notice that I have a 1. So with this 1, what I'm going to do is I need to find a common denominator. I'm going to erase it, and instead of calling it 1, I'm going to call it sine squared over sine squared. And the reason why I'm doing that again is because I want a common denominator, which gives me, as I subtract across, 1 minus sine squared. And you remember, we've been talking about this a lot, 1 minus sine squared is cosine squared. And as you can tell, and as you can see, the left side is now equal to the right side. So, ta-da. So these are the basics of simplifying and proving identities. I know there's a few more left on your worksheets that I could show you that scroll down. They're a little bit more intense, a little bit more time intensive. So what I'll do is I'll model these for you in class, and I can't wait to show these to you. So thank you for watching this video, and I hope you enjoyed the lesson. Thank you.